I don't need to introduce myself anymore, but apart from like being a full stack developer, I'm also a member of AWS Community Builder, and also part of an organization organizers for Data Eng Bytes. So that's going to be one of the activities I added this year. What I'm going to cover in this session, I will start with talking about different components of Amazon Bedrock. There are plenty of features in Amazon Bedrock, and every day there is a new one. So I will focus on the main one. I will talk through what's the common patterns, how we can use Amazon Bedrock within our generative AI applications. And finally, I will showcase a travel and tourist chatbot. Don't worry, I'm not going to just show you, hey, this is a cool chatbot I have built. I'm mainly focused on what will happen behind the scene when we combine those different components and how we can get different responses based on the design that we have in Amazon Bedrock. Let's get started. If you're here, I'm pretty sure you're familiar with foundational models. So I'm not going to explain what are the foundational models, but Amazon Bedrock as a service that provides LLM capabilities in our API layer provide access to a lot of services, a lot of foundational models, a wide range of them. And every now and then we hear that there is a new model is available. One of the advantages of having foundational model with Bedrock is that it's not like you to use one specific model for a couple of reasons. First of all, it's using capability of LLM in the API layer. That means that you're able to switch between one model ID to another one. Initially, when we have the Amazon Bedrock publicly available, there was two APIs, which was invoke model and invoke stream model. Which for those two, you either have to wait until you get the response from model or go with a streaming that it was just populating the response and you were seeing that what model is generating for you. But now with the Converse API, not only you can just have different model IDs, you can even configure your model parameters. So you're not worried about, okay, what if I want to use another model? Secondly, because it's in API layer, you might have an application that has multiple APIs. That means that you can use different models based on the use case of that API and use different model IDs within your configuration. But if you know foundational model, you know that that comes with some restriction and is not tied to using foundational model with Amazon Bedrock. Every foundational model, when you get the inference or invoke them, when they generate the response, they might come with lack of transparency. You're not sure how they have generated that response for you. And also, they might be out of date because the startup or the third-party company that they have trained that model, they might not train that or maintain that model perfectly. Myself, sometimes if I use ChatGPT, it tells me that based on my knowledge in 2020, I don't know how to answer this specific question, and that's very common. But how we can tackle this specific issue? We have a couple of ways. First, we can go with training that model. If you have a specific data and you want to train your model, you can do that one, even within your Amazon Bedrock. You can set up some jobs that train the model, and you can just use that model. Or if you're just using SageMaker, you can train the model in SageMaker and bring the model in Amazon Bedrock. But for LLM models that they have like 70 million kind of parameters, retraining the model, and specifically if you have dynamic data, is going to be time consuming and costly. You need a lot of computation for that. To tackle this challenge, we have another way that I'm going to point out as a second capability of Amazon Bedrock, and that is knowledge base. Knowledge base for Amazon Bedrock, it brings the RAG capabilities. So you can create RAG application with Amazon Bedrock. RAG stands for Retrieve, Augment, and Generation applications. You have two APIs when you create or use a knowledge base. I will in detail explain how you can create knowledge base, but for now, just let's know it as a component of Amazon Bedrock. So you can have invoke API, which is retrieving the data from your knowledge base, and that provides the raw data to user. It doesn't do any augmentation with that. But there is another API which is retrieve, augment, and generate the response based on the context that is taken from your knowledge base. You can also combine it with another component of Amazon Bedrock and provide that RAG capability to the agent. Agent is the other component of Amazon Bedrock, which is one of the main ones. Speaking of that, I don't think agents are really new. Since we had LLM and the models, we had agents. If you search for definition of agent, you will find a lot of definition for that. But for me, it's it is just like takes different action to fulfill the user request. How it does that? It usually breaks down a complex task for your model. Agents behind the scene does all the prompt engineering for you to find out this is the user inquiry, what should I do I have any tools, and based on that tools that it has, it will take different actions to respond to user inquiry. One of the cool features about the agents in Bedrock that I could not find maybe somewhere else, like if you have your own design your own agent, is that you configure it to get more information. When you create agent with Amazon Bedrock, you have this opportunity. You can configure it to go back to the user and gain more information. If it doesn't know how to answer the response, it finds out, okay, I have to go and ask user to get more information before to actually send that inquiry to the model. These are the main components, but I will point out about like other components or the features, especially the ones that are really recent and announced by AWS. But let's just stop it here and talk about the workflows. We know the components. We know there are foundational models. We know that we can create a knowledge base or create an agent. But how we can use those in our generative AI application, that's mainly the most concern. Consider the way that you don't even really have a generative AI application. It's purely your AWS account. You are still able to use Amazon Bedrock. Imagine a scenario that you store your files in S3 bucket and you want to summarize them. You want to translate them. You want to do something which is related to LLM. Simply, you can configure some notifications that trigger the Lambda function, and that Lambda functions invoke the model and does that task for you. So you don't really need to have a web application for that. But the most common pattern is that when we interact with user inquiries or we have a web application, imagine there are common scenarios, the generic tasks that LLM do. You have a topic, you want to generate a story for that. You have like a description, you want to generate an image for that. You want to upload a file and summarize it. So all of these can happen in API layer. What will happen when you have that for your client side? It will trigger an API which has a resolver, which is Lambda function again, that will invoke the model that it will fulfill the task. These two first standard that sounds very simple, they are super powerful when you include the prompt engineering with it. If you have great prompt engineering skills, you can get most accurate responses with these two. Speaking of prompt engineering, I would like to bring up one of the new announcements of AWS, that they have added prompt management and prompt flows. With prompt management, it's very similar to the model cards in SageMaker. What was that the opportunity we had there, we were able to have different models, train different models, and then version them, test them, even do have like A/B testing. And you can do the same thing with the prompts. So you can create different versions of your prompts and then version them. Your prompt engineering team will focus on designing your prompt templates, whereas your development team just developing the generative AI application without being worried about which prompt version I have to use. You will be provided, and you can easily switch that one within your API calls. The next workflow is when we want to include or create a RAG application. Before talking about this workflow, I want to show you how you can create a knowledge base with Amazon Bedrock. For knowledge base, as you see here in the diagram, you only need to have 4 ingredients. First is that your data storage. Again, initially when Amazon Bedrock got available like publicly and I was able to use it, only S3 bucket was our data source, but now you can have Confluence, you can have Salesforce. There are like the list is growing. So you need to provide your data as the external source, and this is very like common pattern when you have super dynamic data. You don't want to keep retraining the model. And whenever you want to provide external information to your model, you store your data. The next one is document chunk. Again, if you're familiar with the machine learning or even the traditional way, you know that why we do that on document chunking. We don't need to fill the model context with a big document, especially the vector models. And also, initially when the Amazon Bedrock was publicly again available, you could just specify the document chunk size. Now you can have a Lambda function that does all of those document chunking for you. When we do the document chunk, again, we are having a smaller size of the document. And what will happen, imagine like a storage. When you have more organized storage, you have more smaller. When you're searching for a specific thing, you know that which area you have to search. With the nearest neighbor search that you do, it will find more accurate responses. So that's one of the another benefit of having a smaller chunk sizes. Then you define your chunk as strategy. The next one, it will be the embedding model that helps you to generate vectors based on your context that you have in your stream or bucket or any other resources. Then our vector database, another benefit of using Bedrock and creating RAG application with Bedrock is that you don't need to worry about the vector database. If you don't have any, when you create a knowledge base in Bedrock, it will create the OpenSearch serverless for you out of the box. Then when you have set up or configured these 4 things, what will you do? You just sync your data. If you go and grab the data from your data source, chunk it, use the embedding model, and create vectors and store that vectors in your vector database. But how is the flow? Like you created a knowledge base. When you use it as a RAG application, what will happen? User inquiry comes in. RAG application use the same embedding model to find the text and search it in your vector database. When it finds the context, it will include it and augment the prompt with the user inquiry, combine those two, and send it to the model and return the response or generate the response. This is very common pattern when you have search application, when you have QA applications based on the documents or some sort of data source. But for myself, it's always a question that, okay, I provide a context to the model. How model knows that to not go beyond that context? And here, one of the other AWS announcement helped me a lot to tackle this issue, and I played with it, and that is the guardrail. So you can have context-based guardrail for Amazon Bedrock. What will happen if the answer of the model is beyond that expectation that you have, which is relevant to your model, to your context you have provided to the model, you can control that. You can even customize the response. If it's not relevant, you say that model is not able to answer to this question. So you can control the model from going beyond or hallucinating and generating irrelevant information. This was another common pattern, but the most complex one, and the one that I have used in my tool, is when agents come in. Whenever you have an agent, any user inquiry that comes in goes through different processes. It's 3 different stages. First one is pre-processing. It will evaluate if your model is able to answer that question. Is it a safe question? Is it any malicious kind of action that going through your model? So it will prevent it to not send down to the model. The next phase is the orchestration. When you create the agent, you configure different tools. It might be a knowledge base or multiple knowledge bases. You can provide APIs, which in context of Amazon Bedrock, we call them action group. You can provide that, and it goes through all of the chain of thought process to find out, do I need to access any external resources such as my knowledge base? Do I need to call an API? Do I need to access any external resource? Or do I need to just go back to the user and ask further question to gather more information? And then once it has that information, send it to the model to generate response and return it back. One of the advantages of using this pattern is that for each stage that we have, pre-processing, orchestration, post-processing, you can do advanced prompting. And that's super helpful because imagine you want to translate or even change the format of the response before go to the user. You can do advanced prompting, post-processing, and then process the response and return it in the correct format to the user. That is the most common one. And there is another way or workflows, and that's when you want to actually fine-tune the model. But believe me, that's a really different concept, and it needs its own time to talk about that one. So when you know the workflows, how we can decide which one we should go with, because they're very similar. Okay, should I go with the specific one, which is API layer, just invoke the model, do the action, or should I create the RAG application? All of this relies on the format of your data and what sort of task you want to do with that LLM model. If it's generic task, just summarize this, convert the text to another format, and it's all LLM-based task, you can use with the prompt engineering. And again, going back to those prompt management and having different prompt flows that enables us to have multiple prompts prompt generates the response. You can output that prompt to another prompt as an input. So you can do a lot of things and not just stick to the model response. And that's really useful. If you have a little bit kind of more complex task, or you require your model understand some sort of data that's tied to your company, and you know that data is partially static, it's not going to change all the time, that is when we can use fine-tuning. You can fine-tune the model to understand your data to respond more accurate and more relevant answers. When we have relatively static data, or you're not even sure about what sort of data you want to train the model, you can just provide that one as an external data source to your model, and that is where the knowledge base come in. And the other approach that we talk about is when we have the agent. Combination of agents and knowledge base to me is more when we want to automate things. Imagine you want to have a chatbot, not only have access to some sort of external data, you also want to automate that flow. For example, someone wants to cancel their order, you want to automate that, and that agent understand task, understand how to fulfill that request, the definition that tells us. So you can combine the knowledge base and agent. That is the most common patterns and how to decide to in which workflow to go with. It seems to be still too fast, but we come to the showcase point where I'm going to talk about the tool that I have with. It's a travel and tourist chatbot. I'm going with the most the most complete version, or the diagram that we saw. I have the agent. I have created a knowledge base. And I will start with the architecture that walk you through how I created different components, how I configured different components, and how I used it. Then I will show you a 5-minute recording, and just go from that. With the diagram, I started with knowledge base again because it's a travel and tourist chatbot. What I did, I stored my different travel promotions. What's the car policy if they want to hire a car? What's the policy for that one if they want to cancel their trip? So this was just dummy data that I found, and I stored them in S3 bucket. Then I'm using again default chunking, but you will find that even with default chunk size, how accurate is the responses. And I put it for 50 megabytes. I'm using Titan embedding model, and I did not have any kind of vector database. I let Amazon Bedrock to create OpenSearch vector for me, and then I synced the data. Then I went to creating the agent. One of the important points, and I think that defines how your agent is going to behave, is the prompt or the detailed description you provide for your agent. I clearly wrote in a very plain English that you're a travel and tourist chatbot. You're going to help my user to plan their trips. You need to gather information, ask them how many people they're going, how long they want to go and stay there, and how much is their budget. And also I provided a couple of tools. So initially, I created knowledge base. For agent, I configure knowledge base. In my case, I only have one knowledge base, but consider that one. Again, the description you put for your knowledge base is super important, because when you actually use the agent, it will decide, okay, which knowledge base I have to use. That's very important to point it out. This is the knowledge base I have to gather this information. Another thing that I did not need it because it was just like a chatbot for myself. When you have the knowledge base and you want to have role-based access, because it's really important, you might have different hierarchy within your company and you want to create a QA. And if you want to your CEO just access to whole data, but your employee just access to portion of data, what you can do when you create the knowledge base, you can have a metadata same as the name of your data. And then when you store it in S3 bucket and you want to sync it, when user inquiry comes in, it will check it against the role and it find out who can access this document. That's also achievable. Then I configured the action group. My action group, I have an emailing service. If some user wants to get the summary of the conversation they had, I have provided an API that just summarize the text, put it in a S3 bucket, generate a pre-signed URL, and return the pre-signed URL in their emails that they can download the file. So I configured this to, again, one important point that it took me some painful way to learn it. When you define your schema, you have a description for each endpoint. Again, that description is another layer of prompt for your model to understand, oh, this is the endpoint I have to use for this specific task. That's really helpful. Then what will happen with this application? When user inquiry comes in, again, agent goes through chain of process after it goes to pre-processing. It finds out, okay, do I need to go to knowledge base? Is this something that model can answer directly? If it goes to knowledge base, it uses the Titan model to do the generating vectors for the user inquiry, goes to my knowledge base. I'm using Claude 2. What it happens, then it can improve, like get that context and send it to the Claude, improve the prompt and augment it, then generate response and return the response to the user. The other use case is when I want to summarize it, and what will happen, it will find out, and that's interesting because in demo you will see that actually agent tells I have to go and use the knowledge base. So when the question is very specific and it finds that it has to use one of the tools, it will use the tool that is the email. For the showcase, as I said, I'm not going to show you, hey, this is the tool that I have built. I'm just, the video has two different screens. The right side is the question. I'm going to read the question for you. You don't need to focus on the right side at all. The right is this way, right? Left side, sorry, my right side, your left side, and the right side is going to be the log. So what I've done when I was like chatting, I have added a lot of logs that is like pre-processing, orchestration, and post-processing. So you will see that how model goes through different like chain of thought, pre-process it to find out, can I answer this? And then it goes to post-processing to find out which tool I have to use, can I generate the response directly? Do I need to go back to user? So you will see all of that, and I want you to pay attention to that side rather than to my typing. Okay. Okay. Oh, before we go to that, I'm asking three different kind of questions. The first question is the very generic one. I'm saying that, hey, I want to go to Switzerland and I want to plan my trip. Give me some recommendation. You will see as soon as every single user input comes in, what model does, it goes to pre-processing. Is it a valid question? Can I answer this question? Is it security risk? And once it's sure, then it will send the question to the model. And what will happen, it goes to the orchestration phase. Here is the phase that it knows that it should come back to me and ask more questions. It comes back to me based on exactly the prompt that I told him. How many days do you want to stay there? How much is your budget? How many people they want to go and stay there. So it's exactly doing what I have asked him from that like prompt. And every single time I'm responding back, it goes through the pre-processing and it finds out, do I need to go to the ask user? You see it's saying that ask user function. That is how it knows that it should go back to the user to gather more information. Once it has all the questions, it will generate the final answer to me. And again, final answer is exactly the template that I gave it in the prompt template when I defined my agent. You could do that with pre-processing, but to myself, it was a really surprise, and it was a powerful thing to see that I just specified one prompt for my agent, and it's exactly following the instruction. It's giving me 4 activities, what's the like cost and everything. Then, that email is dummy, don't worry about that. Then I provide my email address. When I provide my email address, again in my prompt, I told agent, go back to the user and make sure you want to receive the information, which is the summary of this conversation. You might think one of the security risks is, okay, I send you an email and you give me, I will like pull all the data from your like agent. I will ask like funny things to do and grab all your data and send it to me. You can control all of this with the guardrail for Amazon Bedrock. You can control what topics should be asked and all of that. So when I send the email, you will see in the right side, that's the thing that you will find out. It actually goes through, again, pre-processing. When it's going through pre-processing, you will see that it said, I will invoke the send email function to send the email. That's how it identified. Now I have to use the tool that have been provided to me. And that's the response that coming back from the API, and the email was sent to me. So far it was using the general knowledge, and it was using the tool that I have provided. And now I'm just forcing it to give me some information to use the knowledge base. I'm asking, okay, I received the email. Can you give me some information about the refund policies? This is really specific to that travel and tourist agency. It's not like one agency might have different response. So that will be tied to the data that I have provided to the model as an external data. Again, goes through pre-processing and orchestrate the information. And you will see even in pre-processing, it will find out that it's a valid question that seems answerable, by the knowledge base. So it already knows that this categorized in the part of the question that can answer with knowledge base. With knowledge base, something which is different to just use foundational model is that it gives you the source of that information. So this is really transparent. If it's an internal application, you could provide that link, because if user is has the permission to access to that document, they could go and do the further reading through that. Once it has provided the information, it passes it to the model. It just does all those augmenting the prompt and then generates the response. As simple as that, like it's just combining an agent, defining, I even use Claude too, and you will see that, because I did a bit of prompt engineering, how the answers are really accurate. It's not like going and telling me something which is not related to the question that I'm asking. With even Claude 2 on Amazon Bedrock is really performant. Nothing else from this conversation. So the aim for this one was just showing that what will happen behind the scene. How is the chain of thought when you are using the agent, not directly sending the model to question to the model. That almost brings us to the end of this presentation. I hope I could achieve what I wanted to, just to walk you through all the components that we have, how we can use Amazon Bedrock with different combination of the different components in Amazon Bedrock. If you are keen to read more about the new announcement, that I really encourage you to do that, read about the prompt management, because it's a game changer. You can have different prompts and use different version of your prompt in your application. Guardrail is really useful, and you can control even the input. In every single time that you send the response and the question of the user or any query they have to your model, you can use the guardrail to check that if it's a safe thing, instead of waiting for your agent. And even when you generate the response, you can do the same. With Code Execute, I personally have not used it, but it's super powerful when you have sort of analytics questions. It can generate the code for you and then run that code for you and return the response. Or if you have sort of training platform, coding platform, and you want to generate the code and then explain the code, or even validate the code if it's a performant code, you can use that Codex. For the code repository of this one, I put all the code and even the schema of the API and all the definition that you need to have as a the prompt in different layers. Define your agent, define your knowledge base, defining API. And also, if I talk too fast, you can read the blog post. There is still some all the data. Just feel free to scan, and that's pretty much it. I hope you found it useful and I could share some of the knowledge. Thank you. Any question? Yes.
Yeah, hi. Thank you. That was amazing. I'm just interested, obviously we've spent a lot of time on our agent prompt in Bedrock, but it's sort of interesting to hear how much effort you think needs to go into the knowledge-based description. How do you approach that compared to the prompt engineering of the agent?
I think it's totally different concept, because when you have the prompt engineering for the agent itself, I would say the agent is very one of the things I found is useful is that just go plain English. Don't make it too complex. If you just write something which has even multiple questions that ask the same question, avoid that. Going very clear and understandable for the model, that's to me it sounds like a golden hint. But in terms of using that description for different components you use for configuring knowledge base, for example, for your agent, or configuring your APIs, for that one is more what this one is going to do. Rather than, because it's totally different. For your agent, you have to specify what you are being tasked for. And also for configuring your agent, for this example, I configured this should go back to user and ask more information when it cannot answer. And that helps a lot when it finds it, okay, I don't know how to answer this question. It directly comes to your user and asks the question. Again, those questions comes from the prompt that I have provided, because it gives him some idea, or her some idea, that how to go back to user and what sort of question it should ask. And also, again, one of the things, I told them exactly who they are and what they are going to do. That was also very helpful when I played with the agent. And I tried it because at that time, the prompt management did not exist. I have to do all of this, like deploy it and test it. Again, one thing it was really helpful, I tested in console, like just having an alias or a version for my model to be able to just test it with different prompt. And I think for me, the hardest bit was making that agent understand what I am like tasking it. Other than that, the whole agent thing and finding out the tools was like lower priority, and it was easier to understand because the description I gave it to it, again, it's clear and just task specific. You use this knowledge base to give hint or direction about, for example, I don't know, tour and travel. That's very clear, but for agent itself, it's more breakdown, but try to not confuse your agent because the more information you provide, it's gonna be more confused. Like I limited it, I started with the long one, even though console, like in agent, it limits you for a couple of characters. I started with the long one too, so do this, do this, do this, but it was picking the first one, even like it wasn't going down to say, oh, I have another two. Then when I like minimize it, and I think I have included the prompt in the Git repo as well, you will see how simple is that. I'm not like going very crazy and advanced. I'm just going very simple and very because I'm second language speaker, so I usually go with the simple one, simple words, and I think that works with the agents as well. Hope that answers your question.
Yeah, that's great.
Thank you, thanks.
Thanks for the speech. One thing I have found a lot with people using chatbots, for example, or language models, is they don't trust the accuracy of the outcome. How do you measure the accuracy, or how do you showcase to users like how accurate your answer is?
Yeah, that's a great question. For myself, because I was mainly playing with it to understand how it works, for me it was more important how relevant it's answering to my questions, because I wasn't really looking at like comparing the response and finding out if it's accurate in terms of, I don't know, the numbers, if it's analytic things, it's actually writing a right query for me to return back. But again, you can control that with the model parameters. You can control all of those, like how wild your model can go. You can control all of those to limit it to the accuracy. But for my use case or the app I built, I usually was checking, okay, does it understand the question like I'm asking? And if it has a tool and I'm asking a question which is relevant to that tool, does it understand to find it? And then again, with the sort of test, I found that it's again going back to that prompt that I'm providing. If it's not able to find that tool, it's because I'm not giving him clear direction that for this specific category of question, you have to use this. So I think for my use case, especially with chatbot, because I'm not querying any sort of data to compare that, if it's getting the right data that I am asking for, mainly was accuracy is based on the response that model is giving to me.
Yeah, I'll go again. I'm sorry.
Go easy.
I kind of heard the segmentation of database permissions through the role. Where are you defining that? Is that at an application level or is that at an agent level? 2
layers. So you can use, I think, if I remember the service name, but there is a service that you can have is that AVP, if I say it correctly, or AWS verification something? Yeah, I think so. Sorry if I don't know the name, but you can use that one because I was reading. You can configure that one to identify your roles. You can do it that way, or with your files that you store in S3 bucket, you can have the same file, which is the metadata of that specific knowledge base that you're providing, and then that metadata, it tells which roles can access to that specific document.
Just as an adjunct to that question. So you've got a document and perhaps even a document chunk that should only be accessible to certain roles. Is that role information making its way through to the embeddings in the vector database as metadata against the vector?
I'm not sure about that. Yeah, that's something.
I think that's also a pattern.
Yeah.
That you use. So I presume you've chunked up your document. Every chunk gets a vector in a record in the vector database, and there's an arbitrary amount of metadata that you can store against that record.
Could be.
So presumably when you go to do your similarity search, you take a query, you run it through the embedding model, and then you go to the vector database to look for the chunks that are related. You could filter the results by that
Based on that.
metadata, and that way you can only put into the augmented prompt the data that's relevant
Yep.
to that user.
Yep.
Yeah, just back to the embedding side of things. Are you aware of a good chunking strategy, or is it kind of like one size fits all is a good way to do it? Or?
No, so I went with the default one that I just put 50 megabytes and it was just chunking my data with 50. But you can actually have a Lambda function, so you don't really need to rely on that. You can have your own Lambda function, write your own strategy. If you know that, okay, my text should not be truncated like more than this to give a good chunk, you can have a Lambda function that does that for you. It chunk it. So what will happen when it generates the knowledge base, it will use that Lambda function to do the chunking for you, and then it stores that based on that chunk size for embedding.
Is it also data dependent though? So say you've got documents that contain kind of chunks of information that are only a sentence or two long, then you probably
You can
want
control
smaller
that.
chunks.
Yes,
Yeah.
you can control that, definitely. It's very dynamic, especially if you go with the Lambda function one, you can control that. If my document is not bigger than that, this size, even don't chunk it, just send it down.
Do you see a preference towards certain file types or file formats? Like we've been sort of leaning into Markdown, but
Yeah, so I think there is a list of all the files that is supported, especially for knowledge base. I think document .docx, and there are lists that you can see and it says which one is more like supported. But I usually go with doc one. I think it's easier, especially if you work with the Lambda function. Reading those sort of files is easier than like any kind or CSV. It's going to be more easy. Yeah.
A bit of an exploratory question kind of on chunking is we chunk up documents, we turn them into a vector and we can search them. Is there any stock from your experience in creating chunks and then summarizing those chunks, then doing a first pass on like the higher order chunks to work out whether or not you should like dive deeper into the more subdued content or more chunked up versions?
Yeah, so I personally did not experience that. I feel like it's more of you have to test it different times to find it. Especially my docs, it was just like text. And for me, it doesn't really matter like where it's chunking it. But I'm pretty sure for more production kind of projects, you definitely need to go with a better strategy to find out where I have to chunk my documents. And I think the reason even I choose this topic is when you actually use Bedrock in production, you will see a gap between what you learn in like theoretically and how you use it. For us, one of the big challenges we had, because what we do with Amazon Bedrock, we send a lot of requests to Bedrock, and imagine like we have 10,000 calls and we have 10,000 transcripts. We send that 10,000 transcript along with sort of like 40 questions. For all of those, we want to get inference. And what we will like struggle to solve with Bedrock was that because Bedrock is using, especially when you're using the normal, not the provision one, the capacity, what you're doing is you're using the common pool. Everyone is using the same model, different accounts. So what will happen is sends all the requests, and when you exceed your limitation, you will get too many requests error. And then for us, like it took some time to find out what's the workaround. Like I think these sort of things is really experimenting, and both depends really on your data as well to find out how things work for you. For us, like okay, we have to, because there are different strategies. For us, it worked to have a back off and then retry. So that works. Like I think these sort of things really relies on what you are trying to chunk and what you are trying to create vectors from.
Because you can use that Lambda now, you can take a tool set like LangChain that's got all kinds of tools for chunking.
No, yeah, it's a rabbit hole, man.
But you might only want to use it for that one bit. You know, you don't necessarily need to implement everything with it.
I would suggest looking into graph models, like knowledge graphs, for that sort of like hierarchy breakdown.
The LLMs based on jurisdiction, what is, I think at the moment in Australia you can only use Claude, is that correct?
No, we could use Claude 3. You can use Mistral. There are a lot of things. There are a lot of models are now available in Sydney. Yeah, so we are using Claude 3 and Mistral. So especially 3.7b, I think that one is available in Sydney as well. So there are a lot of models now available.
No,
Yeah.
the last look. But there's more for example, in the US?
Yes, absolutely.
And why is that specifically?
I don't know why. Yeah, so it's first.
Most new services go to the US.
Yeah, first it goes to you.
US West 2 or Oregon, and generally the two regions that get most.
That's a good idea.
We fight hard for everyone. If you give us good requests for business value units, we can only hire.
We're happy to be the pilot.
Yeah. Tell us why
I
it's important.
suspect, and I can say this because I'm not with AWS, but there's also a commercial, so yes, they've got to set up a cluster to serve that model to a region, but not all the models are open source. So they're having to do deals with the owners to provide them in those regions.
There's also GPU shortages, so
Yeah.
fighting over them as well.
I think there's only 2 embedding models in
T1 and another one. Yeah, there are 2.
Cohere and,
Yeah.
and Titan. Yeah. In Sydney region.
Yeah.
Yeah. Okay.
More questions?